Nama saya Indah Sepang, NIM 19209045, kelas A Teknik Sipil semester 2. Water pollution. Water pollution refers to the introduction of a substance to the environment, use of a resource, or degradation of the health of humans, wildlife, or ecosystem. Pollution may be caused by point source at stationary locations such as an effluent pipe or non-point source, also called diffuse source, such as land runoff and the atmosphere. The mass flux of a pollutant is expressed as a lot in mass per unit time. Many pollution. Organic waste. Organic matters in water are composed of organic compounds. Generally, most carbon-containing compounds are organic. Excluding steel and simple oxides of carbon, organic compounds include natural compounds, living organisms which are capable of decay, and synthetic compounds which may be biodegradable. Many organic matters are synthetic and not biodegradable, termed refractory organic matters. They include pesticides, detergents, and petroleum hydrocarbons. Some pesticides and other refractory organisms are the principal agents responsible for the decline of creation ecosystem species and are the threats to human health. Suspended solids. Solids in waterway come from mining activities, river dredging, construction, and soil erosion. Nutrients. Nutrients, nitrogen, phosphorus, sulfur, in water and coarse plant, usually in the form of algae. Those nutrients come from domestic, industrial, and agricultural waste. Diffuse pollution from agricultural waste is a major source of nutrients, especially nitrogen. Nutrient-enriched water is more productive with excessive biological activities, and water quality is usually significantly degraded. Eutrophication. Thermal pollution. Industrial cooling process, fossil and nuclear power plants discard heated water into water bodies with effect on reduced solubility of and altered speed of chemical reaction. Thermal pollution changes the natural temperature regime of a water system and the affected ecosystem could be stressed. Some aquatic species may die or are forced to relocate. Toxic metals. They are metals that form poisonous salt compounds. Toxicity is linked with solubility and is directly proportional to its ability to cause environmental damage. Pathogens and carcinogens. Those are disease-causing microorganisms or cancer-causing substances including bacteria, protozoa, dioxins. Domestic wastewater is responsible for many of the pathogens, and industrial and agricultural waste are the usually source for carcinogens. Radioactive contamination. In the natural world, there is always radiation being emitted from radionuclides Radioactive contamination refers to uneaten or undesirable presence of radioactive substance in water, usually from the leachate of stored radioactive materials or released from nuclear power plants accidents. Water pollution indicator. The indicators on water pollution are in their categorical physical: temperature, turbidity, total suspended, dissolved solids. Chemical: dissolved oxygen, COD, BOD, pesticide, metals, and biology. Index strength, biotic index, indicator. Most of them have been explained already in the book, and only a few indicators are further explained here. Oxygen saturation: the maximum amount of oxygen dissolved in water at a given temperature is called the saturation concentration. Biochemical oxygen demand, BOD, is the amount of oxygen required by microorganisms to break down inorganic matters. It is used as an indicator of organic pollution of water. Typical BOD 5 volts, pristine water, up to 1, moderately polluted water to 2 to 8, dilution from more water consumption. Chemical oxygen demand, COD, measures organic matters which are both biodegradable and non-biodegradable. Hence, it covers a more broad spectrum of organic matters. As a result, the COD in water sample is always higher than BOD. Biological indicators are useful to get a general reading of water quality without the high cost of lab-scale analysis. Various are used to represent the states of macroinvertebrates. They are in two types. 1. Pollution index, existence or absence of indicator species. 2. Diversity index, to indicate the overall effect of all pollutants. However, biological indices are not always reliable. Factors other than pollution can affect the biological index. Absence of some species may reflect its normal life cycle, and quantitative sampling of biodiversity is difficult. Wastewater treatment. Wastewater treatment plants receive inflows from domestic, commercial, agricultural, and industrial users, stormwater runoff, and infiltration. Industrial waste may contain heavy metals, radioactive metals, refractory organics, which may be treated on site following specific guidelines. Domestic wastewater is commonly treated in municipal wastewater treatment plants. A main purpose for wastewater treatment is to control pollution of a receiving water body, river, lake, groundwater, and sea. To design an effective treatment system, it is important to 1. Identify the characteristics of raw wastewater. 2. Set treatment objective. 3. Integrate unit treatment operation. 4. Assess the system in view of green engineering, life cycle thinking, and sustainability. That treatment units includes pre-treatment, primary treatment, secondary treatment, tertiary treatment, disinfection, sludge treatment. Water quality modeling. Water quality models are used to analyze environmental systems and predict water quality change due to modification in catchments and wastewater treatment plants. The prediction provides a basis for engineers to carry out economics analysis to evaluate various options to improve the environment. Water quality models are based on 1. The law of conservation of mass material transport into and out of the control volume as a physical process, and 2. The change of substance in the control volume transformation of the substance due to biological and or chemical process. Material transport refers to the movement of the substance from one point to another, which involves adverse movement with the fluid and diffusion or dispersion spread in the fluid due to difference in concentration. Water quality standard for pollution management. Water pollution is usually managed by following water quality standards. Water quality standards are established by legal to define the level of pollution allowed in a water system. There are 3 types of standards: receiving water standards and effluent standards. Receiving water standard refer to water quality standard for receiving water bodies, rivers, lake, sea waters, and effluent standard refer to the quality of effluents described to receiving water. The aim of both types of standard is to achieve the desired quality of water system. The receiving water standard considers the use of the water system, swimming, irrigation, drinking, industry. Effluent standard set the required maximum pollutant concentration to be achieved or the degree of treatment required before described. Both standards are regulated and should be met. Water quality standard must be reasonable so that discharge should be able to achieve the standard through the available technology. Solid waste management. Solid waste are defined as unwanted materials that are no longer of use to their owners, albeit they may be still of use to other authorities. They are generated from various human and animal activities. Each year, billions of tons of solid waste are generated, which are in need of proper treatment. Improper management of solid waste has direct adverse effect on human health and the environment. Source and composition. The information on waste composition and generation rate is important for proper planning, treatment, and disposal of solid waste. Some solid waste, industrial, agricultural, and mining, are managed by the waste producer. In this chapter, the focus is on the municipal solid waste, which include residential, commercial, institutional, construction, and demolition. Another way to classify waste is to divide them into biodegradable, spoiled food, green waste, recyclable paper, glass bottles, cans, insert, construction and demolition waste, electrical and electronics, composite waste, waste clothing, Tetra packs, waste plastics such as toys, hazardous paint chemicals, fluorescent tubes, spray cans, fertilizer, toxic, pesticides, herbicides, fungicides, medical, pharmaceutical drugs. Waste properties. Solid waste management option depend on physical and chemical characteristics of the waste. Waste generation rates are expressed in mass unit instead of volume unit. This is because waste densities vary greatly among the wastes with different compaction at different stages in the waste system: collection, storage, and disposal. The information on waste moisture content is used to derive dry mass of the received waste. In addition, for energy recovery design, it is important to know the energy content in waste. Plastic and paper have high energy content and low moisture content. In contrast, garden waste are less productive in energy release due to their high moisture content. Storage, collection, and transport. This part of the waste system typically account for 40 to 80% of the total cost. For residential waste, the most common collection method is curbside. The waste are usually segregated into different containers according to waste types: foods, garden waste, recyclable. Recycling. Recycling is to convert waste into new product. It can reduce the consumption of raw materials. Recyclable materials include glass, paper, metal, plastic, textiles, and electronics. Energy use, air pollution from incineration, and water pollution from landfill. Successful recycling requires careful consideration of the processing capacity and the markets for the recycled goods. Potential demand for the recycled products. If neither of them exists, recycling is incomplete and in fact only collection. The most benefit of recycling is complex, economical. A major benefit is the reduced landfill costs. Other benefits can be worked out by comparing the market cost of recyclable material to the cost of new raw materials. Composting. Composting is a microbial process used to treat biodegradable waste. This too similar to aerobic wastewater treatment. Composting has several purposes. 1. To reduce waste mass. 2. To reduce pollution potential. 3. To reduce stored pathogens. And 4. To reduce compost as nutrient for gardens, landscaping, and agricultural organic farming. Incineration. Incineration, waste to energy recovery, is a process to liberate the energy in waste by combustion. This is suitable for waste with high energy content, low moisture content, and low ash content, which include paper, plastic, textiles, rubber, leather, and wood. Incineration produces two solid byproducts, bottom ash and brown water, and fly ash, suspended particulate matters. There are six commonly used incineration systems. 1. Mass burn for unsegregated solid waste. 2. Modular small incinerators for specific waste such as medical waste. 3. Refuse derived fuel energy right waste as fuel to power plants. 4. Co-incineration to combine with production waste. 5. Hazardous waste pathogens and toxins destroyed by high temperature. And 6. Common kilns as fuel for common production. Landfill. A landfill site is a site for the disposal of solid waste by burial. This is the oldest form of waste treatment and the most common method for waste disposal in many places of the world. In a landfill, waste are packed into solid form and converted to insulate them from water and air. Usually every day with layers of soils. Leachate is a liquid drained from the landfill as a contaminated wastewater. In a new landfill with oxygen still available, organic matters decompose and carbon dioxide is produced. As time goes by, the remaining oxygen is consumed and an anaerobic condition leads to the production of methane gas. Alternative technologies. In addition to the aforementioned traditional technologies, many new approaches are undergoing development. They include anaerobic digestion, alcohol, ethanol production, bio-drying, gasification, in-vessel composting, mechanical biological treatment, mechanical heat treatment, plasma art waste disposal, pyrolysis, tunnel composting, and waste autoclave. Solid waste management. The combination of different components should be considered as a whole in a holistic way to serve the needs of the current and future generation. Good policy should be developed by analysis policy options with assessment in costs and benefits, risks, and unintended effects. The priority in a waste management policy is the reduce the waste and followed by reuse and recycle. The 3RC. The 3RC are expanded in Europe into a waste hierarchy: reduce, reuse, recycle, recovery, and disposal. Air pollution. The earth is surrounded by gas called air which form the atmosphere. The atmosphere is a complex, dynamic natural system essential to support life in the air. The air interacts with water and land. A giant rain falling on the ground is a result of air pollution. Many pollution, such as particulate matters, heavy metals, and ozone are able to influence water quality and ecosystem function. On the other hand, polluted rivers, lakes, and sewage systems can cause air pollution in their surrounding areas. Therefore, it is important for a water engineer to understand the air, its related quality issues, and vice versa for an air quality engineer to understand water pollution. Composition of air. The composition of dry air is listed in table composition dry air by NOEE. Structure of the atmosphere. The Earth atmosphere has distinctive layer with a total mass of 5, their quarters of which is within the bottom. The atmosphere becomes progressively thinner with altitude without a boundary. However, the common line at about the Earth's sea level is commonly used as the boundary between the atmosphere and outer space. Beyond this altitude, the atmosphere becomes too thin to provide sufficient aerodynamic life to support any aeronautical vehicles within the orbital speed of the Earth. The atmosphere is divided into several layers based on temperature profiles: troposphere, mesosphere, stratosphere, thermosphere. Transport of air. The movement of air is divided in two categories: the outdoor environment, ambient air, and indoor environment. Global transport. Among the layers of the atmosphere, the two layers near the Earth surface are more relevant to air pollution. Regional transport. High and low air pressures dominate regional air transport. Local transport. Due to the different temperature between land and sea in the coastal area, the wind direction changes during the morning and evening. Indoor air. Indoor air quality has a significant impact on human health. Design of ventilation system in a building influence temperature, humidity, and pollutant movement. Air pollutant. Air pollution is the introduction of a substance to human and the environment which may be natural, volcano eruption, or man-made. Pollution can be solid, liquid, or gaseous. Major pollutants include nitrogen dioxide, sulfur dioxide, particulate matter, ground level, ozone, carbon monoxide. Emission estimation and control. 3 or 5 methods to quantify air pollutant emissions. 1. Direct measurement, either stationary sensor or mobile sensor. 2. Mass balance and indirect way by the conversion of mass form the inference between the measured inflow and outflow in a system. 3. Process modeling by mathematical modeling of physical and chemical process. 4. Emission factor modeling. Emission factor is the ratio of emission and pollutant source intensity and can be found in the published manual. The short intensities such as time its relevant emission factor to discern the estimate emission rate. 5. Expert judgment. Subjective estimation by experience and knowledge. The reliability and cost are ranked from high to low with the method 1 to 5. Method 1 is the most reliable and most costly, and method 5 is the least costly and less reliable. 5 options to control air pollution. 1. Prevention, green chemistry, green engineering. 2. Regulatory solution, permit for allowable emissions monitoring. 3. Market solution, a total allowable emission caps is set and emission allowance can be traded in the market. 4. Voluntary solution, voluntary emission reduction by individuals, communities, and firms, encouraged by easy access of air quality information. And 5. Emission control technologies, thermal, oxidizer to oxide, pollutant using high temperature in a similar way to incinerator absorption by passing pollutant air through water, soaked media in a similar way to a smoking water pipe, biofilter filled with a biological medium for the polluted air to be passed through to interact with the attained microorganisms, and particulate emission control technologies such as cyclone, scrubber, backhouse, and electrostatic precipitator. Air quality modeling and forecasting. Air quality is modeled by air dispersion models, also called atmospheric diffusion model, air quality model, or air pollution dispersion model. A set of mathematical equations, physical and chemical processes of air and its pollution is solved by numerical methods on modern computers. The dispersion model is used to estimate or predict the downwind concentration of air pollution emitted from various sources. Air dispersion models can be used by government agents to determine whether an existing or new industrial plant will be compliant with the relevant air quality standard. A typical air dispersion model requires information on 1. Meteorological condition, wingspan and direction, atmospheric turbulence, ambient air temperature, the height to the bottom of any inversion, aloft that may be present, cold cover, and solar radiation. 2. Pollutant source, the concentration or quantity of pollutant in emission or accident release, temperature or the material source location and height, type of source. 3. Terrain, elevation at the source location and at the receptor location, and use and cover information. Thank you.